Hello, we're going to start talking about lesson 4.2, which is all about functions and graphs. And I want to start out by just showing kind of a metaphor for what we're talking about. So this painting that I have up here is called Guernica, and it's by Picasso. And Picasso was one of the originators of Cubism. Cubism is a form of art, a form of expression, and it was a new way of representing reality. So he saw something. In this case, he had been observing the Spanish Civil War in the beginning of the 20th century, and this was his interpretation of it. Clearly, this was not happening in real life. This does not look like real life, but it was his representation. So he took something real and transformed it into this piece of art. And that's kind of what mathematical relationships do, is they take an input, they put it into an equation, and then out will come an output. Okay? So we're going to talk a little bit more about that. Let me switch my screen. So we have a whole bunch of different ways of representing relations. I have 4 written down right here. We have a table, an equation, a graph, and a diagram. So a table, I've also referred to it as an input-output table before. We'll have 2 different columns. So on the left, we have the input, which is usually denoted by X, but really it can be any letter. And then on the right side, there's the output, or the Y. And again, it could be any letter, but usually it's Y. The input-output table can also be written horizontally on its side, but I will almost always do it vertically just because that makes more sense for me. So in addition to a table, we have an equation. An equation is just written with variables and numbers, and it shows a way of relating 2 or more variables to one another. A graph is on our coordinate plane where we have our y-axis and our x-axis. Each grouping in this table shows up as coordinates on our coordinate plane. Okay? Similarly, each grouping here in the table comes out of this equation. So our x, our input, is our independent variable. That's where we start. So I choose any of these numbers, and then I can plug it into my equation, and what I would get as my output would be over here in this second column. The 4th way of denoting a relationship is what we were looking at yesterday. And these are diagrams where we show our domain and our range. Again, the domain is our set of inputs. And our range is our set of outputs. And this diagram just shows how the different members of the domain will map to the different members of the range, the different elements. Okay? So again, a relation in math is, you can think of it as, I kind of think of it as like a machine where you put in an input and then the machine kind of works on it and does something to it, and then out on the other end comes that output. So input and then output. And a function, as we learned in 4.1, is a specific type of relationship in which each input has exactly one output. Each input has one output. So we can check to see if a relation is a function from our table or from an equation by just checking to see if any x values have more than one y value. any x values have more than one y value. So if an x value has more than one y value, x value has more than one y value, then that is not a function. So let's find an example of that where an x value would have more than one y value. Maybe you guys are familiar with absolute value. Absolute value. That's when we have those two lines on either side of a variable or a number. So the absolute value of a number, let's say 4, is going to just be 4. It's going to be 4. But the absolute value of -4 is also 4. So it does kind of exactly what we said it's going to do. It's going to pull, it's not going to pay attention to the sign, it's only going to pay attention to the value of that number inside of here. So I'm going to set up a relation that includes absolute value. So I have the absolute value of y equals x. Okay. So if I were to choose any number for x, any number as an example, let's say 6. So let's say for x equals, and I'll set up a little input-output table. So if I choose 6, so I say the absolute value of y is 6. Well, I know the absolute value of 6 is 6, so that would work. But I also know that the absolute value of -6 is 6. -6. Therefore, one x value produces 2 different y values, and therefore that is not a function, not a function. It's a relation, we can still graph it, but it will not be a function, right? And then if each value produces only one y value, if each x value only produces one y value, then that is a function, is a function. So let's use an example again. Let's say we have y equals x minus 3, x minus 3. And again, we can kind of create a little input-output table. And let's just choose a couple values for x. So if I choose 5, and I plugged that in here, I would get y equals 5 minus 3. Well, y equals 5 minus 3, y would equal 2. Y equals 2. Y is never going to be able to equal -2 or any other number. It can only be 2 because 5 minus 3 only equals one number. It can't equal more than one value. So this is a function. That is a function, right? You guys are going to do a few practice problems like this in your investigation. And it might feel a little tricky at first, but I want you guys to just give it a try. And I'll post another video where I'll go over it with you, so you'll have an opportunity to see kind of my thinking on it, okay? But basically, if you can come up with an x value that will produce more than one y value, that is not a function. And if each x value produces only one y value, then it is a function. Okay? Let's see. So we can also check to see if a relation is a function by using something called the vertical line test. I really love the vertical line test. I don't know why. I just have always thought it was really cool. And it's definitely the most it's the easiest way to determine whether a relation is a function or not. So what we do with the vertical line test is we'll be given a graph. So I have 6 different graphs written out here. And you can take I'm looking for a straight edge, like a ruler, or you can use the side of a piece of paper. And basically what you do is you want to take that vertical line and cross over the entire graph. And what we're looking for is to see if ever we put a vertical line on this graph, if that vertical line ever crosses 2 points at once. So we can see as I move this along this graph, I'm only crossing the graph at one place at a time, the whole way across. So if it only crosses at one place at a time, then it is a function. It is a function. But if we use that same test, same vertical line test, and there's any point where we're crossing the graph at more than one place, then that will not be a function, not a function. So right here, that vertical line crosses 2 places at once. That cannot be a function, not a function. Let's try this squiggly. So again, I cross over the whole thing, and I can see my vertical line is only crossing one place at a time, one place at a time, all the way across. So this is a function. And how about this one? So as I'm going across, I'm only hitting one place until I get there. Now I'm hitting 3 places at once. So again, not a function, not a function. All right, this one might look a little different to you. This is called piecewise, piecewise. So it's broken up into different pieces. And you'll see that on the left side of these different pieces, we have a filled in circle. That means we want to include that value. But on the right side of these little lines, we have an open circle. That means we don't want to include it. We don't want to include that value. So again, let's try the vertical line test. So as I'm going over here, clearly along this piece, I'm only hitting one. I'm only hitting one part of the graph. But then when I get here, it looks like we're hitting 2 places at once, right? We're hitting this piece and that piece. However, like I just said, this left side of the graph here, this left side of that little line is filled in. So we do include that piece. But down here on the right side of this part, we don't include that piece. Therefore, right here at this value, we're only hitting the graph up here. And same for every other place. Therefore, this is a function. This is a function. Okay? And now the last one is a circle. Maybe you remember this from the turtle crossing Desmos activity, where we were drawing a graph of the turtles walking away from the water. If you drew a circle, and I think this circle was given to you in one of the exercises, you saw that the turtles split into 2, and one was walking away from the water, one was walking toward the water, and then they came back together and went on. So that is an example of something not being a function, is not a function. And again, we can see that with the vertical line test, that we have 2 places at one point. So again, not a function. Okay. And the way that this vertical line test works is again, remember the definition of a function. We have, for every input, we have exactly one output. For every input, we have one output. Our inputs are generally put on the x-axis. Our outputs will be along the y-axis. Therefore, if something is a function, At any point along the x-axis, there can only be one place on the graph. For every input, there can only be one output. And then when something is not a function, I would have one input, this would be my input along here, but two separate outputs show up. And that's why that is not a function. Again, just to state it again, if a vertical line crosses the graph in more than one place, that is not a function. And if a vertical line cannot cross the graph in more than one place, then it is a function. Right? Now let's look at an example of a few different relationships that exist in real life, and we're going to determine whether or not these relationships represent a function. So they're all given in the form input first, output second. Again, just keep thinking about our inputs are generally our x, and our outputs will generally be our y. That's why it's in that order, just like the ordered pair x and y. Okay, so let's look at the first one, city and zip code. So city will be our input, zip code will be our output. So if that would be a function, then every city would have exactly only one output, only one zip code. So I think around here, for the most part, cities only do have one zip code. Cortez is 81321. However, in bigger cities, generally, there will be more than one zip code. So if, I forgot the second part, if this relationship does not represent a function, we're going to find a counterexample. So a counterexample is just a way of proving why it wouldn't be a function. So for my counterexample here, I'm going to give Detroit. Detroit has many more than one zip code, but I lived in two different zip codes. One was 48201 and 48214. Okay, so a city can have more than one zip code. So this is not a function, Okay. Now, person and birth date. So every single person, think about it, and you can pause the video right now and just think about it before I get the answer. Think about person being the input, birth date being the output. Can one person have more than one birth date? No, of course not. We can only be born on one day. So each person has one birth date. The input person produces only one output. Okay, so this is a function. Okay, I'm recording. Okay, so last name and first name. Think about, can a last name as an input produce more than one different first name? Can a last name have more than one first names associated with it? Pause the video, think about it, then come back. So yeah, of course, more than one person can have the same last name. And I'm going to offer a counterexample. Weasley. There are many Weasleys. Is there an E there? I think so. There's Ron Weasley, and there's also Ginny Weasley, as well as many others, right? So more than one first name can be associated with the same last name. So that is not a function. right? And now the last one, state and capital. So think about it. How many capitals does each state have? How many outputs can be produced from the input state? Think about it, pause the video, and then come back. Yeah, so each state has only one capital, only one capital. So this is a function. Okay. One last thing I want to show you, and this is just kind of a note-taking tool that I think would be helpful. This is called the Freyer model, and it just kind of helps to reiterate what we just learned here about functions. You can use this for any vocab word, but we're talking about functions. So, but what we do is you write your vocab word right in the middle, and then you split your paper into 4 sections. So you'll have the definition, you'll have characteristics, you'll have examples, and you'll have non-examples. So you guys can work on that on your own, and I'll post an example of mine later on today. All right, cool. I hope that this has been clear and helpful as we start learning more about functions. And yeah, as always, if you have any questions, please reach out. I'd love to hear from you. Hope you guys are having a great day.